Today our topic of discussion is projectile motion. So projectile motion is mainly of two types. Here in this picture, this projectile motion is ground to ground motion, and in picture B the projectile motion is height to ground motion. So these are mainly two types of projectile motion. In for one case we are projecting a particle from this, let's say this is the point A. We are projecting this particle with a velocity u at an angle with the horizontal theta, and this particle, the motion of particle is like this, and it is falling coming to point B. So this is one type of projectile motion, and another type of projectile motion is that is depicted in point B. That is, we are projecting the particle from this point A horizontally with the ground, with the velocity u. Okay, and the angle that the projectile is making with the horizontal is 0 degree. Actually it is parallel to horizontal plane, but we are projecting it at a height of h. Compared to this, we are projecting it from the ground itself and with an angle theta, and it is going it is traversing this path and it is falling in B. But here we are projecting the particle from a height h from a point A with angle 0 degree with the ground, means horizontal to ground, with a velocity u, initial velocity u, and it is falling in the point B. So these are main two types of projectile motion that can come in JEE or NEET or any entrance exam. So we'll discuss these two types of projectile motions here. So before discussing this, we have to know some assumptions used in projectile motion, means some rules, some aspects of the projectile motion. Like for point 1, there is no air resistance on the projectile. Means when we are solving example of projectile motion, means when we are solving some problems regarding this projectile motion, we should not take into account the air resistance, okay, the resistance due to air, because if we include the resistance due to air, then the calculation will be somewhat different. Means we have to then include the resistance of air also, that the dynamics of the particle will be different. So here, for the sake of simplicity, we don't include air resistance in the projectile motion. But in real life the air resistance is there, but due to the problem that the course we are talking about, means in the scope of this topic, we exclude the air resistance phenomenon. Then the effect of Earth's curvature is negligible. Means the Earth's gravitational force changes with height. Okay, so in higher the gravitational force will be changed with altitudes, but the Earth's and that is due to the Earth's curvature. Okay, because in the equatorial region, if we are in the equatorial region, then Earth's radius is different, but if we in the polar region, the Earth's radius is different. So for this difference of radius, this acceleration due to gravity will be different. But here we are not taking into account the curvature of the Earth. Means we are assuming that the Earth is a sphere with radius r. Means in all over the surface of the Earth the radius is same, so that the acceleration due to gravity is same in all over the Earth's surface. So the Earth's curvature we are not taking into account when for solving this projectile motion problem. And another aspect is no effect due to Earth's rotation. Means the Earth is rotating around itself and around the sun, so there, for due to Earth's rotation, a force named as Coriolis force acts on the body. So that will impact on the projectile motion. But here, for the sake of simplicity and for the scope of this topic, we are not taking into account the rotation of Earth. Okay. Now let us discuss the ground to ground projectile motion. Okay, so let's assume that a particle of mass m, here is a particle, it is projected from point A, okay, with an initial speed of u, and we are projecting this particle with an initial speed of u, and we are collecting this particle at the point B. So particle is traversing this path. So this is ground to ground projection. From means we are projecting the particle from ground and we are collecting it on the ground itself when it has traversed some distance. So this velocity u, initial speed u, will have two components. Like in the horizontal direction, it is making an angle theta with the horizontal axis. Okay, so it will have mainly two components perpendicular to each other. One is the x component, that is here it is angle u, so the x component will be u cos theta, and one is the perpendicular component, means y component, that is u sin theta. So during the projectile motion, now we will talk about the acceleration that is working on the particle in the projectile motion. So acceleration in the x-axis, ax, will be 0. It means that there will be no force in the x-axis. Force in the x-axis, f of x equals to 0. Acceleration is also 0. Means when the component of the velocity that is along the x-axis, that will be remain same during its motion. Means the no force is acting on the x direction, so the particle will maintain a constant velocity during the along its x-axis. So we can see that the initial x-axis velocity is u cos theta. So we can also conclude that the final x-axis velocity will also be u cos theta. Okay, but in the y direction, in this direction, the acceleration of the particle will be due to the acceleration due to gravity g. Here the acceleration in the perpendicular direction, the particle will the means acceleration due to gravity will work on the particle in the y direction. So in the y direction, the velocity of the particle will change. Let's suppose the initial velocity is u, then the perpendicular component of velocity is u sin theta. So when the particle is starting from this a-axis, its initial velocity is u sin theta, and the acceleration of the particle is acting in this direction. Okay, here g. In every point, the acceleration due to gravity is working on the particle along the negative y direction. So its y-axis velocity, initial velocity, is along the positive y direction. Acceleration due to gravity is acting on the negative y direction. So its velocity in the y direction will decrease and will come to 0 at the highest point of its path. Okay, here the velocity will be y-axis velocity will be 0. Here the particle will come to at rest. Okay, but here also the x-axis velocity is u cos theta, but the y-axis velocity is 0, because the acceleration force due to acceleration of gravity will completely nullify the force along y-axis due to the projection. Means the force, that is acceleration due to gravity, that will completely nullify the force that we are projecting the particle in the y-axis. So here from when we start from here, that when its velocity along y-axis is u sine theta. So here when it is going, its velocity is decreasing, and here it will be 0. So if when the particle pass this point, so again its velocity will increase, and from 0 it will increase, and just before falling on the ground again, its velocity will be u, again the previous value, that is the starting value, that is u sine theta, but its velocity will be in the negative direction. At that time this velocity was in positive y direction, but before falling to the ground, its velocity will be negative y direction with the same value, means u sine theta minus u sine theta. Or you can say that u sine this is j cap, u sine theta of minus j cap, means velocity is u sine theta, means the magnitude is u sine theta, but the direction is minus j cap, means negative y direction. So initial velocity, if we break the velocity into two components, x component and y component, so initial velocity vi equals to u cos theta I cap plus u sin theta j cap. Final velocity vf is u cos theta I cap, same, because the x-axis velocity will be same during its projection but the y-axis velocity will be minus u sin theta j cap. So change in velocity delta v, that is v final minus v initial. V final is u cos theta I cap minus u sin theta j cap minus v initial u cos theta I cap plus u sin theta j cap. So this will result in delta v equals to minus 2u sin theta j cap. So this is the change in velocity. So if we multiply this with the mass of the particle, so this will become the change in momentum delta p equals to mass into change in velocity. Here is m is the mass, and m into minus 2u sin theta j cap. Okay, so if total time for this motion is t, then force acting on the particle, force F, this is, we know that force is rate of change of momentum dp dt, means change in momentum minus 2 mu sin theta j cap divided by t. This will be the force acting on the particle. So now we will learn some important formula of this ground to ground motion. Okay, like the range the particle is traversing from A to, let's say, B, what range it is traversing in the horizontal direction, that is R range, what is the maximum height it can achieve from the ground, that is H max, and what is the time of flight, means how much time does the particle take from into going from A to B along this path. Okay, so let's say this point is H. So to deduce these relations, we know that the perpendicular direction in the y axis, its initial velocity is uy equals to u sin theta, and as discussed earlier, I said that its velocity along the y direction decreases gradually up to point H, and after that it increases again, and just before falling on the B point, its velocity is again, its along y-axis velocity is again u sin theta. Okay, before just falling to the B axis, just before falling to the B axis, its velocity is again u sin theta, and then when it is falling to the B point, its velocity is 0. So it's in the h point, its velocity, final velocity along y-axis vy, we can say that vy equals to 0. So from here it is in decreasing velocity, decreasing, here it is 0. So we can write from this, from vy, we can write that vy square equals to ey square plus 2gh. Actually it will be, when it is accelerating, this equation v square equals to we know v square equals to u square plus 2fs. Sorry, we know that v square equals to u square plus 2 into f into s, where v is the final velocity, u is the initial velocity, f is the acceleration, s is the distance or height. Here v is, here this v equals to vy, this u equals to uy, this f equals to acceleration due to gravity. But here this acceleration will come into account when the particle is going downwards, but here particle is going upward. From point A to point H, particle is going upward, so f equal will be negative of acceleration due to gravity minus g, and s will be the height, means the height it is traversing, from 0 to h max. So we get this equation here, vy squared equals to uy square plus, actually this g will be negative, okay, here minus 2 into g into h. Now vy, we know vy equals to 0, okay. So if we put vy equals to 0 in this equation, we get 0 equals to uy square minus 2 into g into h, or h equals to uy square minus 2g, and uy is initial velocity along y-axis, that is u sin theta. So u sin theta square by 2g, that will be equals to u square sin square theta by 2g, that is the h max. We can write here h max, maximum height that can be achieved with the particle in this projectile motion. This is the important equation for exam point of view. Many questions come from this equation in the exam, NEET or JEE. So and another thing that we have to work out is the range. What range the particle is traversing, means AB. Here AB, this distance equals to range equals to r. So we can say that the particle is going in a constant velocity from A to B along x-axis, and that velocity is ux equals to u cos theta. With this velocity it is traversing the x direction. In the x direction velocity is not changing. So we know from the constant velocity, if a particle traverse in a constant velocity v with a time t and traverse a distance s, so s equals to v into t, where v is the constant velocity, t is the time that is the particle taking to traverse the distance, then s is the distance, then s equals to vt. So we can write that range equals to the constant velocity along x-axis u cos theta into t is the time of flight, t is the total time when the particle is traversing along this axis. If the total traversing time is t, then we can say that the particle is taking t time only to go from A to B, means the time of the projectile motion time and AB distance traversing time will be same. The range equals to u cos theta into t. Now we have to work out what is t, means what is the value of this traversing time, total time of traversing, what is the value of this traversing time. So again, for this to calculate t, we have to make resort to the formula, that is v equals to u plus ft, f into t, where v is the final velocity, u is the initial velocity, f is the acceleration, t is the time. Now again we will consider, I will write the graph here, projectile motion here. Initial velocity is u, here u sine theta, here u cos theta, here h max, this is the point h, this is the point a, this is the point b, here h max, here velocity vy, means y axis velocity vy equals to 0, এখানে uy equals to this and ux equals to this. So if we apply this equation along the y axis, then this will come like vy equals to uy. Now deceleration, gravitational deceleration is happening, so deceleration due to gravity, we can accelerate, we can term is a deceleration due to gravity, like minus g into the traversing time. And like traversing time, we can make this like small t, okay, from the time the particle takes to go from a to h, we can take this time as small t. This is not the total time the particle is traversing from a to b, this is the half of the time the particle is traversing from a to h. And to make the total time, means if we want to calculate the total time, then the total time t is be 2 into small t, that is the double of this small t. Small t is the time the particle is taking to go from a to h, okay, that time we are calculating. So vy equals to 0, uy equals to u sine theta minus gt, so t equal to u sine theta by g. Now the total traversing time, capital T, will be 2 into small t, it will be 2 u sine theta by g. So we know that traversing time equals to 2 u sine theta by g, okay. Now we know that range equals to u cos theta into this traversing time, means u cos theta into 2 u sine theta, here from here this formula we can substitute t with this formula, 2 u sine theta by g, 2 u sine theta cos theta by g equals to u 2 sine theta cos theta, we can write as sine 2 theta by g. So okay, sorry, here it will not be 2, it will be this will be 2u, okay, 2u. So here it will be 2u sine theta, then 2u square sine theta, then u square sine 2 theta will be g. So range will be u square sine 2 theta by g, okay. So what are the main 3 equations we have to memorize for exam purpose? That is r equals to, range equals to u square sine 2 theta by g, t equals to 2u sine theta by g, and h max, another formula is h max equals to u square sine square theta by 2g. So these are the three most fundamental equation for the projectile motion, and these are very important equation. You have to memorize this. Please memorize these three equations. You must memorize these three equations to solve any problem in projectile motion. Okay. For to clear the concept, like I have a problem to clear the concept question. Like we are projecting three particles. Okay. Three particles A, B, C we are projecting, like here, like this. A particle we are projecting like this, B particle we are projecting like this, C particle we are projecting like this. This is A, this is B, and this is C. Okay, y axis, x axis. Now their range are different. Okay, for A, this is the range of A. For B, this is the range of B. For C, this is the range of C. But height, the maximum height they are attaining, h max, is the same. Here you can see from the graph that they all are attaining a maximum height h max that are same for the three particles. So what is the relation between their time of flights? What is the how their time of flights are related between each other, means for which particle time of flight is greater, and for which particle the time of flight is less. Means how is the time of if time of flights of three particles are Ta, Tb and Tc, then which is highest and which is lowest? That you have to answer from the figure. Okay, from the range, like particle A has the smallest range, like here particle A, range of particle A is smallest, range of B is middle, range of C is high. Then how will be the their time of flight is related, like which time of flight will be highest and which time of flight will be lowest? Now this is a very easy question. You just have to keep in mind that two formula that I have proved here, two formula, that is h max, maximum height formula. H max is uy square by 2g, and another formula is this time of flight formula, that is 2uy by g. We can see from this formula that h max solely depend on proportional to uy, and t is also proportional to uy. Now H max is same for the 3 particle. H max is same, and we are not, means G, the acceleration due to gravity G is also same for 3 particle. So Uy, you can write this in another kind of ink. Uy is same for 3 particles as H max is same, but time of flight T is proportional to Uy only. As H max is same, so we can conclude that Uy is same, but time of flight is also proportional to Uy, means time of flight, as if Uy is same for 3 particles, then time of flight is also be same. T is also same for 3 particles, means if H max is same, then time of flight is also same. Okay, H max is same, then time of flight is also same. So guys, let us discuss one last problem in this topic. So the problem is, a large number of bullets are fired in all directions with same speed u. What is the maximum area on the ground which these bullets will spread? Means here is a gun, okay, and bullets are firing with this gun in all direction. Okay, bullets are firing here in this direction, with this direction, okay, like these things. Okay, I am writing with in a clean manner. In this direction, in this direction, in this direction, in this direction, like these bullets are being fired. Different angle, with the different angle with the horizontal. So this bullet will fall here, this bullet will fall here, this bullet will fall here, this bullet will fall here. So what is the maximum area? So you can see that if bullets are fired in all direction, then the bullets, the area in which the bullets will fall in all direction will make a circle, this type of circle. Okay, in the area of these circles, all the bullets fired will fall. This is a maximum area of the circle in which the bullets fired in all direction will fall. So we have to calculate the area of this circle, this area. So to calculate this area, we have to know the radius, this radius, because circle's area equals to pi into radius square. So this radius will be the range, like bullet is firing from here, and this is the maximum range that a bullet can cover. So that will be the radius. Radius will be range, maximum range of a bullet. So now from here we see that the formula R equals to u square sin 2 theta by g. So we will write this equation, range equals to u square sin 2 theta by g. Now all bullets are fired with same velocity, same speed u. All are fired, means for all bullet u is same. Okay, but theta u is same theta varies for bullets, for all bullets. Now for maximum R max will be u square by g into maximum value of sine 2 theta. Now for sine or cosine, the maximum value is 1. So u square by g. This will be the maximum value of the range. So we can tell that we can conclude the area would be pi, maximum area, max area, be pi into maximum radius square. Radius equals to maximum range, means r max square. R max, will be the radius of the area. So pi into r max square. R max equals to u square by g, the square equals to pi to u to the power 4 by g square. Answer. So this will be the maximum area on the ground which bullets will spread. In this maximum area, the bullets will spread on the ground. Okay. Thank you.